Hello everyone, welcome back to Believer Science Academy, Bengaluru. This is topic of the day discussion session. In today's topic of the day, the topic we are going to study is KM3NET project. We will see what is KM3NET project and what is its significance and what is its relevance and everything. Okay, why it is in news? It is in news because scientists are deploying two advanced telescopes under the Mediterranean Sea as part of the Kilometer Neutrino Telescope project. So KM3 is nothing but KM3 in the sense KM cube net. Okay, KM cube is cubic kilometer neutrino telescope, and it is neutrino telescope. Okay, by this you might have understood that it is a telescope aimed at studying neutrinos. Okay, and it is present at Mediterranean Sea. Then what is KM Cube Net project? KM3NET is a European research initiative launched in 2012. So it is not a new initiative. It has been launched previously, but now and it is located in the Mediterranean Sea. Why it is in news? It is in news because two new telescopes have been submerged in the sea. That is why it is in news. It uses advanced water Cherenkov detectors to study high energy neutrinos and their origins, as well as fundamental neutrino properties. Okay, so neutrinos are one of the few 6 fundamental particles. It is similar to electrons, but electrons have a negative charge, whereas neutrinos have no charge at all, so they are neutral in nature. Okay, so in order to study these neutrinos, KM3NET project has been launched by European agencies. Then what are the key components of this? First one is ORCA in the sense astroparticle research with cosmics in the abyss. Abyss is nothing but seabed. Okay, so it is ORCA is present in offshore Sicily. Sicily is in Italy at 3,400 meters depth. It studies high energy cosmic neutrinos. One is ORCA is in Italy. Another one is ORCA. What is ORCA? ORCA is oscillation research with cosmic in the abyss. Okay, this is astroparticle research. This is oscillation research. Where it is present? It is present in offshore Toulon, France, and it is at a depth of 2,475 meters, focusing on neutrino oscillations and mass hierarchy. Okay, ORCA studies cosmic neutrinos. Here it studies neutrino oscillations, how the neutrinos are oscillating, and what is its impact. Okay, so the KM3NET project detects Cherenkov radiations. A Cherenkov radiation is a faint light produced when neutrinos interact with the water molecules using 6,210 optical modules. Okay, so this Cherenkov radiation, whenever this Cherenkov radiation happens, then there is a reason for the happening of Cherenkov radiation. That reason is neutrinos interact with water molecules. Okay, so if there is Cherenkov radiation, then there has to be neutrinos around it. Okay, only when neutrinos interact with water particles or water molecules, it is going to produce Cherenkov radiation. So you are not directly detecting the neutrinos, you are focusing on this Cherenkov radiations. Once the Cherenkov radiation is present, then you will be understanding obviously that the neutrinos are also present here. Okay, this Cherenkov radiation is very important. There can directly be a question in prelims regarding this Cherenkov radiation. So Cherenkov radiation is related to neutrino particles and its interaction with the water molecules. Okay, then so the design of this KM3NET project is, it has a modular construction with plans to deploy 12,000 optical modules. These are optical modules, so they want to deploy 12,000 optical modules of such thing on 600 vertical strings anchored to be seabed. Okay, in the abyss. So in the image it looks like this. Okay, it looks like this. There will be 12,000 such objects. They will be dropped into the seabed in a 600 vertical columns. Okay, so it is a mega project only. So mega project aimed at detecting the neutrinos. and these are connected via electro-part optical networks to shore stations for power and data processing. Okay, so this electro-optical network, whenever they identify any Cherenkov radiations, that will be captured using electro-optical network, and this is connected to the shore stations, and then the shore stations come to know that there has been a Cherenkov radiation, meaning there has been an interaction, then we can study the neutrinos. Okay, and then, so what is neutrinos then? Why is studying neutrinos very important? Neutrinos are subatomic particles which are similar to electrons but without an electric charge. Neutrinos have, if electrons are negative charge, neutrinos have no charge. Okay, so whereas photons have positive charge. Then neutrinos are the second most abundant particles in the universe after photons. Okay, then approximately a billion neutrinos pass through a cubic centimeter of space every second. Okay, within just a cubic centimeter space, around 1 billion neutrinos pass through. Even though there are 1 billion neutrinos passing through just a cubic centimeter space every second, they are still very difficult to be identified. Okay, because they are very faint in nature and they don't interact with the common particles. Okay, that is why it is very difficult to identify them. That is why in order to identify them, we have neutrino observatories. It was initially detected in 1959, though their existence was theorized in 1931. High energy neutrinos are those which originate from exotic astrophysical events like supernova, gamma ray burst, or colliding stars are of particular interest to scientists because, okay, so within the neutrinos there are high energy neutrinos which are produced by cosmic events such as supernova, gamma ray burst, etc., etc. They are mostly important to scientists because these are the second most abundant particles in the universe after photon, and these high energy neutrinos are easier to detect compared to the normal low energy neutrinos. Okay, then why do you study neutrinos? Okay, let them be there. Okay, what is the need of studying neutrinos? What is the use of like spending so much of amount of money on neutrino observatories where you can spend that money somewhere else? Okay, it is important to study neutrinos because they provide insight into particle physics, including the neutrino oscillations and mass hierarchy, which is challenging the standard model. There is a standard model of fundamental particles of in the physics, such as muon, electron, okay, up, down. There are some 6 fundamental particles, but this study of neutrinos is going to challenge the standard model. Okay, then neutrinos pass through dense cosmic regions, offering access to areas invisible to traditional telescope. Okay, if we can somehow harness the neutrinos, we can easily pass through the dense cosmic regions which the normal visible rate cannot be transferred. Okay, using those neutrinos we can observe areas which you would normally be unable to observe. Okay, then studying neutrinos also aids in tracing cosmic ray origins and understanding dark matter and unlocking mysteries of the universe. Okay, so there are mysteries of universe such as dark matter, dark energy, big Higgs boson particles, etc., etc. Those can be studied more effectively if you have a better understanding of neutrinos. Okay, then there is also a connection with India. What is the connection with India? India does have a Indian Neutrino Observatory. Okay, so India is not very far behind in this field as well. India has a Neutrino Observatory. It is present at West Bodhi Hills in Theni districts of Tamil Nadu. Okay, so it is present in West Bodhi Hills, and it is present in the Bodhi Hills Underground Observatory. It is underground because neutrinos have a weak interaction with the matter and they can be better identified in the underground where there is less interaction of neutrons with the other matters. Okay, so this point is very important. Although this is a world news, since KM3NET project is in news, there can be a question relating to neutrinos and relating to India. So that is why this topic becomes very important for us. Though it is a very small topic but very important, there can directly be questions on this one in the prelims, and there can sometimes be a question on your mains also, and there can be a discussion about this in your interview as well. Okay, so this ends our discussion. If you like the video, then hit the like button, comment on it, and share with your friends. And if you are new to the channel, please subscribe to the channel and also click on the bell icon so that you don't miss any notification. With this, I will end the video. Jai Hind.